Hey everybody, we are talking today about limiting reactants. Yesterday, you guys did a activity about building cars with engines and bodies and tires, and you're figuring out how many cars that can be made. Today's really just an extension of what you did yesterday. I'm going to give you a similar example to the cars to start with, and then we're going to go into some more chemistry based examples. Here's just a little problem similar to yesterday. In the problem says we have 8 cups of dough and 3,000 chocolate chips. If it takes 2 cups of dough and 22 chocolate chips to make 8 cookies, the question on the table is how many cookies can we make? One thing I hope you notice about the ingredients, just taking a quick look. Obviously, 8 cups of dough and 3,000 chocolate chips is not very proportional. So the problem here is we have way more chocolate chips than we have dough. So the problem is that we will run out of dough long before we run out of chocolate chips. In other words, the dough will limit the amount of cookies we can make. The key word there being limit. So, what we're talking about today is limiting reactants and excess reactants. In each problem that you are given today, one of the reactants will limit the amount of product we make, and the other will be present in excess. Now, to define limiting reactant, I would say it is the reactant that runs out first, or it completely reacts. Another way to think of this is the limiting reactant produces less product. Now, that second statement is really what I would be thinking if I were you in terms of how to attack a problem. The excess reactant is the reactant that will not run out. The excess reactant produces more product. It's those second 2 sentences in both these definitions that's really what we're going to use today. Now, we've talked about how to recognize one problem versus another. I just want to refresh your memory. In a typical mole conversion problem, we have one given, and we are starting in substance X, and we are ending in substance X. So we're not really changing the substance. The substance is the same. We're just changing units. In a stoichiometry problem, we also have one given. In this case, we start with substance X, but we end in substance Y. That's what you guys quizzed on last week. A limiting reactant problem. We are no longer going to be given one piece of information. We are going to have two givens, and they are both going to be reactants. We are going to convert both reactants to the same product. And the reason why we are doing this is we want to see which reactant produces less product and which reactant produces more product. That'll help us identify the limiting and the excess reactant. Let's start with a simple example with cookies, one that we don't have to do chemistry with. So in this reaction, we say that 2 cups of dough plus 22 chocolate chips will produce 8 cookies. Now, this problem's easier because there's only one product, so it's really easy to know where we are going to convert. So B is the actual question. How many cookies can you make if we have 16 cups of dough and 68 chocolate chips? Notice that we are not given one piece of information, we're given 2 pieces of information. So in my first conversion, I'm going to take 16 cups of dough. And again, we want to convert dough into a product. The only product here is cookies, so we're going to convert dough into cookies. If dough is on top of my fraction, we're going to need dough on the bottom, and in the equation we have 2 cups of dough. So we know that 2 cups of dough will produce 8 cookies. Now, that's really all we have to do to get dough into cookies. Use our calculator. 16 times 8 divided by 2 is the dough will produce 64 cookies. Now that's great, but we got to see what the chocolate chips will make. So we have 68. I'm just going to put CC for chocolate chips. In our equation, it says 22 chocolate chips makes 8 cookies. So we're going to put 22 chocolate chips to get those to cancel out. And we are going to make 8 cookies from that. So 68 times 8 divided by 22 gives us so the chocolate chips will produce, looks like about 24 cookies. Now, you have to then take this information and interpret the information. The first question is, what is the limiting reactant? Remember, the limiting reactant makes less product. So, which reactant made less cookies? Well, the dough made 64, the chocolate chips made 24. So, I would say the chocolate chips are the limiting reactant. The next question says, what is the excess reactant? The excess reactant makes more product. The dough produces 64 cookies, so we would say that the dough is the excess reactant. And then the last question says, how many cookies can be made? You cannot make more cookies than the limiting reactant will allow you to make. So if the dough makes 64 and the chocolate chips makes 24, we can only make 24 cookies. So after your conversions, whatever the lesser amount of product is, that's how much product you can actually make. And that's all you're doing today. You are taking your 2 givens, you're going to convert them both into the same product. You're going to analyze which one makes less product, and then you're just going to fill out these questions. Now, let's do an actual chemistry example. It says ammonia is made by combining hydrogen and nitrogen. It says if we start with 144 grams of nitrogen and 144 grams of hydrogen, answer the questions below. And these questions are asking the same thing that our previous questions asked. What is the limiting reactant? What is the excess reactant? And how many grams of product can we make? So step one is we are going to convert nitrogen to NH3. It says we have 144 grams of nitrogen. If grams of nitrogen is on top, we need grams of nitrogen on the bottom. Now, hopefully at this point, you guys know how to make or calculate molar mass. So we have 2 nitrogens. 2 times 14.01 is 28.02 grams of nitrogen. And we are going to convert to 1 mole of nitrogen. Now we need to convert from moles of nitrogen, which is right here in our equation, into moles of NH3. In our equation, it says we have 2 moles of NH3. Now we need to go from moles of NH3 into grams of NH3. To calculate the mass of NH3, it's going to be 14.01 plus 1.01 times 3. That looks like 17.04 grams of NH3. We're going to multiply the top, divide the bottom. 144 times 2 times 17.04 divided by 28.02 is 175 grams of NH3. And what we should put is that nitrogen produces 175 grams of NH3. Now we've got to convert our hydrogen. So we also have 144 grams of hydrogen. And we're going to basically go through the same process, grams to moles, moles to moles, moles to grams, just like last week. 1.01 plus 1.01 is 2.02. And that is equal to 1 mole of hydrogen. From the equation, we actually have 3 moles of hydrogen. So 3 moles of hydrogen is equal to 2 moles of NH3. And we already know that 1 mole of NH3 is equal to 17.04 grams NH3. Grams of hydrogen, moles of NH3. That's going to leave us with grams. 144 times 2 times 17.04 divided by 2.02 divided by 3 is 810 grams of NH3. And again, what we should put is that hydrogen produces 810 grams of NH3. We just did all the hard work. Now we just have to interpret these questions. So, which is the limiting reactant? Well, nitrogen produces 175, hydrogen produces 810. Whichever reactant makes less product is the limiting reactant. Therefore, nitrogen is our limiting reactant, meaning that hydrogen is our excess reactant. And then if I ask you how many grams of product is made, in this case, you can't make more product than the limiting reactant allows. So this is your amount of product that's made. So 175 grams of NH3. All we are adding to what we did last week was instead of doing one conversion, we're doing two conversions. And then we're interpreting those answers to figure out the limiting and the excess reactants. Now, I'm going to leave you one question to do during class. So I want you to use what we just did. I'm going to grade you on this for homework. Obviously, you're going to get points for already taking the notes that you took. But right now, you're going to use this example. You're going to convert iron to 3 oxide and carbon monoxide to iron, and you're going to solve the question the same as what we just did. So complete this question in class, submit it, and you guys are good for the day, and we'll see you guys tomorrow.